Welcome to my first live. Sorry for the technical problems. My name is Soufiane Karoubi. I will be presenting a conference I created called Which Future for Our Generation? This conference will be a bit longer than the one I first planned to do in real life because it's through internet, so you can pause, you can have a rest, you can go back to it later, and also because I have some dear friends who are watching, so I wanted to add some elements and spice it up. First of all, I'm not an expert in the subject we're going to talk about. I'm just merely someone who is watching a lot of videos on internet. Know that I have an engineering background. So when I talk about physics or energy, I know a bit what I'm talking about, even though, of course, I'm not an expert. Right now, I'm a web developer and gymnastics teacher. I only do websites for companies or associations or individuals which are trying to do eco-friendly stuff. So if you are in need, I'm very cheap. I live in Poland. And to enter the per se lecture, what we're going to see will be not pessimistic, but rather realistic. If you feel like what I'm saying is pessimistic, please try to write down wherever you want where you felt like I was pessimistic, and then we can talk about it. I will simply not accept any comment at the end where you just say, I think you're just pessimistic. Please try to be specific. What will we see in this conference? Here is the summary. First, we're going to see the limits of our Earth system. Then we will see how the situation we're in is a predicament. Predicament is a word in English which is a problem which doesn't have a solution. For example, cancer or diabetes is a predicament. You just have to live with it. Then we're going to talk about collapsology. We'll explain what it is. And finally, we'll talk about solutions. Not solutions to avoid the disaster, but rather solutions to make the disaster on a smaller scale and thus saving some lives. Don't need this anymore. Up. First, the planetary limits, and the most famous one is climate change. I won't spend too much time on climate change, but just to give rough figures, here we are. The first thing to understand about climate change is what does it mean to have a 2, 3, 4, 7 or 15 degrees increase in temperature. What I'm going to do is I'm going to describe to you the weather, how it is, the climate, how it is right now in Europe and how it was 20,000 years ago. While I do so, please try to guess what was the difference of temperature on average on the planet, which led to such different climate in Europe. You can see that right now the climate is rather temperate, and if you take man out of the map, it's rather forest. 20,000 years ago, it was a complete different story. We are in the middle of the previous ice age, and the climate would be the one that you can find right now at the north of Siberia. It's very cold, very dry. You have a 3 kilometers thick ice sheet, which is taking a nap on Sweden, Germany, and all the Nordic countries. And I'm not sure if they can see this or not. Sorry. Uh, this ice sheet has two big sisters, one over Canada and one over Greenland. All this ice, of course, didn't magically appear from nowhere. All the water came from the sea, which means that the sea level was about 120 meters lower than it is today. This means, for example, that there is no North Sea, no Baltic Sea, and you can go on foot from France to UK. What do you think is the global temperature difference on the planet, not between those two Europes, which led to such different climates in Europe? You can You can write the answers in the chat if you want. If you're watching this video not live, I recommend you to pause, think about it for a sec, and then we'll see the answer. I saw one answer, answer number B. Yes, you are correct, Lama de Bois. The answer is B, 5 degrees. 5 degrees is all it took to go from the climate on the left to the climate on the right. 5 degrees on average on the planet. That means, we need to understand that the climate reheated over a period of 5,000 years. So, in 5,000 years, the animals, the plants especially, and humans had time to adapt. Imagine such a difference over a period of 2 centuries. Plants won't have time to adapt. Simple as that. Second feature is what we call positive feedback loop. Opa. Positive feedback loop is kind of a vicious circle. Okay, it's an action which reinforces its cause. So, for example, the most well-known is the permafrost, but I'm gonna take the one of the Amazon forest because I'm a thug, and that's it. Imagine that the Amazon forest is taking a lot of carbon, but when the climate is too hot, then the trees start to die, and then the trees are releasing their carbon into the atmosphere. This reheats the climate and then makes it even more hot, and then more trees die, which releases more carbon, and then you have your vicious circle. What you can see on this figure is that you have mainly three types of positive feedback loop. The yellow one, which are activated between 1 and 3 degrees, the orange one between 3 and 5 degrees, and the red one over 5 degrees. And the problem is that if we reach 3 degrees, we will automatically, this will activate all the orange one by one, and after some time, not straight away, this will lead us towards an increase of temperature of more than 5 degrees, activating the red one, which will even more reheat the climate. So if we reach 3 degrees, we automatically go over 5. What's our current trajectory? Right now, we are about at plus 1.1 degrees since 1850s. And what the IPCC is telling us, this could be summarized as this. At plus 1.5 degrees, damages can be managed. This means that a few islands disappear. You have forest fire like we can see in Australia quite often. Damages can be managed. At plus 2 degrees, you have important damages, but still manageable. This means anything between a few dozen and a few 100 million people dying. It's important, but you still can manage it because most of the people who will die in poor countries. And let's be honest, we don't really care. I mean, I do, but let's be honest, we just don't care. At 2.5 degrees, most of the yellow feedback loops are activated, and we have a high risk of reaching plus 3 degrees. At plus 3 degrees, the climate goes out of control, and what the IPCC is telling us is that at plus 3 degrees you have food problems for most of humanity. This means war everywhere, basically. At plus 4 degrees, 3/4 of the Earth becomes unlivable. That means you can forget about everything which is south of Sahara. And at plus 5 degrees, agriculture becomes impossible, so we're all dead. When I say we're all dead, it means that most of the human race is dead. Of course, the human race will not go extinct. We're extremely resilient. But it's the difference between humanity with 8 billion people or just a few millions. The Paris Agreement, when you take everything that the all the NDCs from the countries, which means everything that the countries signing the Paris Agreement said, I will do this, I will do this, I will do this. If you put everything together, this leads us to an increase of plus 3.5 degrees in 2100. And we're not even in phase with those Paris Agreement. We'll see why in a sec. The current trajectory is as this. So this is not from the IPCC, this is from the CNRS, which is one of the biggest research centers in France. So since I'm French, I chose to show you this graph. What you can see is, first of all, there is no way of returning back to 1.5 degrees, of going towards only 1.5 degrees in 2100. What you can also see is that in the worst case scenario, we have an increase of plus 6.5 degrees in 2100, and in 2080 we're all dead. The two curves at the top are not so realistic because this means that climate doesn't influence us, that even if it's plus 5 degrees, then we can still continue to emit. The most likely one is the purple one, which still leads us to plus 3.5 degrees, which is not that good. The next big problem is climate lag. There is about 20 years between the time when the CO2 is emitted and when the CO2 has finished to have its effect on the climate. So this means that we have a 40 years cognitive time lag. We are currently having the effect of the CO2 which was emitted 20 years ago, and even the CO2 we're emitting right now will have an effect on the climate, will finish to have its effect on the climate in 20 years. This means one thing, that whatever we do, even if we cut all CO2 emissions tomorrow, then we will reach plus 1.5 degrees. Okay, at some point we will reach plus 1.5 degrees. The CO2 is just already in the atmosphere. If we put all of this together, so this is, I made the calculation, so take it with big quote marks. With a 2% increase of greenhouse gases emission for the next 15 years, it's literally the end of the world in 50 years, even if we stop all our CO2 emissions in 15 years. That being said, what will happen to our generation? Mainly, I chose those threats, but there are way much more. I just chose the one I preferred and the most impactful. Well, the ones I think will be the most impactful. First thing is a water crisis. For example, we can calculate that the Himalaya glaciers will be melted in 20 years during the hot season. This means no water for 3 little rivers like the Ganges, the Indus, and the Yangtze-Kiang. We have a problem of desertification and deforestation. Know that deserts are currently 25% of current continental land, and they are expanding. For example, in 25 years, Beijing will be surrounded by a desert. We have a problem of oceans acidification. This means that while we emit the CO2, one part of this CO2, actually the biggest part of the CO2 we're emitting in the atmosphere, gets absorbed by the ocean. But by doing so, the ocean is starting to be more acidic. And this is problematic, especially for coral reefs or for phytoplankton, because they cannot form their carapace, their shells. They cannot form their shells because the water is too acidic, and 50% of our oxygen comes from phytoplankton. No big deal. This is not a problem for our generation, but everyone talks about it, so I had to put it somewhere. I put it there. It's the rising sea level. Understand that this problem is mostly a problem for very, very, very future generation. But right now, with the increase of temperature, Okay, sorry, my headset just turned off. Um, right now, with the increase of temperature, we are deciding if the sea level will rise in the next few centuries or millennials by 2 meters or by 8, 10, 15 meters. Okay? Plus 2 meters means that most of the South Pacific Oceans, Southeast Asian countries will be underwater. Bangkok, Shanghai, uh, Jakarta, this type of city. Most of Netherlands, Belgium, well, joyful. I will just check if I still have some sound. Sorry, as I said, it's my first live, so 2 meters means that yes, I do. Yes. Okay, sorry, it's my first live. I'm not very good with technical problems with OBS and things like this. Climate change, of course, also means more storms and more floods, or more droughts and more heat waves. More means more frequent, more often, but also more powerful, and that they last longer. Okay, so that was for climate change. I think we can easily understand that climate change is one of the biggest challenge of our generation, and that it has the potential power to almost wipe out humanity. But CO2 isn't everything. We have other type of pollution. Very quickly, we have, for example, atmospheric pollution, which kills each year, according to WHO, more than 9 million people. Or we have like plastic pollution. Plastics are everywhere, like it's raining plastic in the Pyrenees. Babies are born with microplastics in their blood. Well, just to give two examples, but we have many more different types of pollution. Pollution with heavy metals, light pollution, sound pollution, etc. Biodiversity, the situation is even worse than for climate change. That's what we're gonna see. We are currently in the sixth mass extinction. Not officially, because in order to be in a mass extinction, you need to have wiped out 75% of all living creatures on the planet. We're close to that, but we're not there yet. And just during the time I'm gonna do this conference or this lecture, about 10 species will have been wiped out from the surface of the Earth. The thing to understand about biodiversity is that it's currently not related with climate change. Climate change is influencing biodiversity loss, but not so much. The biggest factor influencing biodiversity loss are the way we do our agriculture with deep labor and the use of pesticides, and the fact, most importantly, the fact that we're cutting down forests like crazy. And thus animals simply don't have any places to live anymore. A few examples: we've lost 80% of flying insects in Europe over the course of the last 30 years. This is mainly due to pesticides usage. We've lost 90% of worm population in the last 70 years in the world. This study was made only on 52 countries, I think, but I generalized in the whole world. Um, this is mostly due to the way we do our agriculture and deep labor. We've exterminated 60% of wildlife in the last 40 years in the world, mainly due to the fact that we're cutting forests to make some fields to produce more food, mainly for animals. And overfishing also has its consequences. We've lost 90% of the big fish biomass since the 1950s. And of course, 25% of the remaining species are now threatened. Agriculture. So I'm going to present to you a slide. I literally shit myself when I made this slide, and I was aware of all those threats, but I made a summary of all the threats which I just told you about for agriculture. Our pollinators are disappearing. Our birds, our insects, our soils are more and more dead, 90% of worms less. Our oceans are more and more empty. It's been calculated that in 2050 there will be more plastic than fish in the sea, and that we won't be able to make significant fish catches in 2050. We're gonna have some big problems with water. We're putting concrete everywhere, especially around big cities where the land have been historically very good. This is why big cities have established there. Deserts are gaining some momentum and are expanding faster and faster. Sea level rise, as I said, it's not so much for our generation, but a +1 meter increase of sea level would mean that the delta of the Nile or the delta of the Mekong would be underwater. And this, according to the IPCC, would happen before the end of this century. More and more storms and flood, more and more droughts and heat waves. Understand that what's important is not the average temperature, but if you have 5 days in a row with over 50 degrees of temperature, then the crops you planted for the whole year are ruined. Of course, we're gonna have human migrations. So if we're nice, and I would like us to be nice, we should find a way to feed all those people who will come to Europe because of the mess we've made with our atmosphere. We're gonna have insect migration, of course, and our plants may not be prepared for this. Soil erosion, I didn't mention it because I didn't have time, but this is also a big problem because of the fact that we're putting concrete everywhere, because of the fact that there are droughts. Then when you have a lot of rain, all of a sudden, the big surface is that the big problem is that it washes away the layer of humus which accumulated and took a long time to accumulate at the top of the soil. And two problems that I will, well, phosphate, I won't mention it, but every living thing need phosphate in order to form their DNA. And what we're doing is that since we're taking the phosphate away from the field to feed the plant, and then we're not putting it back to the field because we're not putting our poo back into the field, then we need to mine the phosphate from somewhere, and the peak of extraction of phosphate should be around 2030, 2035. That being said, it doesn't mean that we won't have phosphate anymore. It just means that from 2035, we will have less and less and less with a growing population. And finally, something we're going to discuss will be that we're going to have less oil and gas in the near future. Near future, understand, like in the next 10, 20 years. This is a problem because we are doing our fertilizers with gas, and we're putting oil in our engines, but also because we need oil to transport the food. So take a deep breath, pause this video if you're not watching live, and just check. Do you think that we won't have any problems in the next 30 years with agriculture? My guess is no, but here maybe I'm being pessimistic. Another thing to understand is the limits we're hitting with metals. I won't have time to develop too much this part, but When we talk about metal, we talk about everything which is gray in the Mendeleev table that you can see here on the screen. So most of the elements are metals. And right now we have about 20 metals which are judged as being critical. To know if a metal is critical, we look at the reserves of this metal, we look at the pollution to extract this metal, and we look at how important this metal is for our societies. What's important to notice is that we need those some of those 20 critical metals in order to do the energetic transitions. It means to decarbonate our electricity production. For example, for nuclear, we need a lot of sand to do the nuclear power plants, but we also need things like beryllium. For renewable energy, more on that in a sec, we need things like indium, gallium, and copper, a lot of copper actually for solar, dysprosium, neodymium, copper, and sand for wind power, also a lot of sand for hydroelectricity. Why renewable? Because even if the energy source is renewable, meaning the wind is renewable and the sunlight is renewable, the thing we need to extract this energy and turn it into electricity uses metals, which are not renewable. Okay? And now we're gonna talk about energy and economy. This part of my work, this part of the conference, of the lecture, is mainly based on the work of Jean-Marc Jancovici. Go and watch one of his videos. This is like a 10-15 minutes summary of his 2 hours conference. Go and watch his conferences, they are amazing, and he talks about it way much better than me. First of all, I know next to nothing about economy, but I understand physics. Based on this assumption, we're gonna start with physics because I prefer this part. What is energy? You have the technical definition at the top. Simply put, energy is the thing which characterizes a transformation. For example, if I push my lighter right here, I applied a mechanical energy in order to change the velocity and the position of this lighter. This energy can be thermal if I heat some water, chemical like in batteries. Biochemicals is your body changing and transforming food into a lot of heat, a bit of movement, or electrical, so I can talk to you through this computer and internet. We're going to compare the energy content of 1 liter of oil and the energy content, how much work a human would need to do in order to produce that much energy. So we're going to do a thought experiment. I would like you to take your beautiful car, you put 1 liter of oil inside, and then you drive straight. Most likely you will do about 15 kilometers. Then you turn the car around and you start to push it. How long do you think it will take you up to come back at the point where you started? How long do you think it would take you to push about 2 tons car through 15 kilometers? If you're watching the live, please pause, and if you're not watching the live, please pause and think about it. Otherwise, I'll be waiting for some answers in the chat. The answer is 7 days, pushing 7 hours per day. Sometimes you see that it's the energy content of 1 liter of petrol is worth 21 days of manual labor, but here I took into account the fact that the Carnot cycle, the engine of the car, is only giving, assuming you're that the current cycle of the car is giving you only 30% of the energy contained in the oil. So that's why I have 7 days, and sometimes some people are saying 21. This means that in order to do the same transformation, because energy is the mark of transformation, oil is between a few hundred and a few thousand cheaper than human labor. This is not a coincidence that, by the way, slavery stopped when we started using fossil fuel, because even with a very inefficient engine and even with a slave, used oil is way much cheaper than a slave, because a slave you need to pay to protect him from the wind, you need to pay to feed him, to clothe him, to prevent him from killing you or from running away. A machine doesn't complain, a machine just obeys, and a machine doesn't tire as long as it has oil. We're going to see a few examples. Here is an average human person. Well, you're welcome, ladies. And this human can produce a power of 100 watts with his legs or 10 watts with his arms. The person inside this tractor who is drinking a bit too much beers can work the field and transform a field as much as 600 pairs of legs. This is why as soon as you put energy into a system, then the amount of agricultures dropped. For example, 2 centuries ago, the average normal farmer in France could produce enough food for himself plus half another person. Today, France has 2% of people who can feed everyone, and 2% of agricultures, and we're even exporting food. The person driving or piloting this backhoe, also drinking a bit too much beer, is as strong as 10,000 pairs of arms. Good example for this would be the fact that Notre Dame burned this year, and actually last year. Oh, time flies. It took 150 years to build Notre Dame at a time when we didn't have oil, at a time when we didn't have machines. Right now, Macron wants to build it again in 5 years. I don't think it will be that quick, but this wouldn't even be possible, humanly possible, if we didn't have oil. The person driving this truck is as strong as 4,000 pairs of legs. This means that in order to move the things which are in this truck as fast as the person driving this truck, you would have to put a bike with 4,000 people on it, and then the payload at the back. And the person, the pilot flying this plane, also drinks a bit too much beer, not in a great shape. This guy is literally Superman. This guy is as powerful as a bike with 1 million people on it. Imagining that they are all coordinated and synchronized. But how much energy do we have? Here comes the notion of energetic slaves. Energetic slave is the energy which could be produced by a slave working 24/7 for you. And you can see that in the world, every person has access to the energy which would be produced by 200 people biking on a bike 24/7. 200, it's an average. Actually, in Europe, we're more around 400 or 500 per person. Note that Louis XIV. I'm sorry, it's because I don't have any sound in my headset, so it keeps turning off. Note that Louis XIV just had 50 slaves, so you're way much richer than Louis XIV. And the consequence of this is this perfect correlation between energy and GDP. Because so what can we see here? We can see on the abscissa axis, so the horizontal axis, the energy consumption of the world, and on the vertical axis, Mr. Jancovici put the GDP of the world. And for each year, he made a dot. What you can see is a perfect correlation between energy consumption and GDP. This is not surprising. This is just because in order to produce more GDP, GDP is just a measure of things, resources you extract from the environment, resources that you transport, that you transform, and you make funny toys with it that you then sell. And you have your GDP. Correlation, of course, doesn't imply causation. Okay, it could be that because we have more GDP, then we are richer and we can consume more energy. But everything I just explained, the fact that energy is the thing helping us to transform our resources and helping us to do our to create our GDP, proves that energy gives you GDP and not the opposite. Another thing that proves it is this. You can see here the very nice correlation between, in red, the oil consumption, so and the GDP. So GDP growth and oil consumption growth in volume. Okay. What you can see is that each time, first the oil goes down, oil consumption goes down, and then the GDP follows. First the oil goes up, and then the GDP follows. This is very true for energy. This is very, very true for oil, because oil would be the backbone of our societies. More oil means more transport. And in world like we have, which is completely and fully interconnected, well, maybe not during coronavirus, but fully interconnected, less oil means less GDP. Now we'll get interested into the future of our energy supply and especially about oil, because this is the future of our economy. First, let's look at a few things. This graph shows us where our energy comes from. You can see first that most of our energy, thanks, give me a sec, because I'm talking a lot. Thanks. You can see that most of our energy comes from fossil fuel, meaning coal in gray, oil in blue, and gas in pink or purple. So you can also see that the energetic transition, meaning replacing an energy with another, has never happened. We have never extracted and consumed as much coal, oil, or gas as today. What the economists who are telling you, yes, we're going to continue to have growth and we will decarbonate our energy supply, they mean that the red thing, meaning biomass, so the wood, the kind of blue-green thing, which is hydropower. In red you have nuclear, and in green you have tiny. I hope you have your glasses, because in green you have all the new renewables, meaning solar, wind, geothermia, tidal waves, etc. Everything which is supposedly renewable, but which is not biomass or hydropower. What they tell you is that those four things will replace most of the coal, meaning more than 90% of the coal, and half of either the oil or the natural gas in the next 30 years. Personally, I don't believe it, but maybe you can call me a pessimist. What's important, so we're gonna have a look at oil especially. What we need to understand is oil is a finite resources, and mathematics, not even physics, mathematics proves that when you have a finite resource, the curve of extraction of this resource can only have this shape. At minus infinity, it's 0. We haven't extracted anything. At plus infinity, it's 0. We've extracted everything we could extract. And between the two, you have, this way, you have a maximum, which we usually call the peak. And there is a petroleum engineer called Marion King Hubbert, an American, who in the 50s showed that usually between the peak of discovery and the peak of consumption, you have about 40 years. This is because you need 40 years to put in place the infrastructure to extract your oil. So here you have conventional oil, you have the discoveries in blue and the production in yellow. We're going to talk about unconventional oil in a sec. What you can see on this graph is first that the discoveries peaked in the middle of the 60s, and that since the middle of the 1980s, we are consuming more oil than we are discovering. Currently, we are consuming about 6 times more than we are discovering every year. And actually, Marion King Hubbert wasn't wrong because the peak of conventional oil happened in 2005. The official number is 2008, but actually we reached a plateau from 2005. In 2008, you had like a small dip, which was the maximum, and then it started decreasing. 2005, the conventional oil started to flatten, conventional oil extraction, and 2008 economic crisis. This is not a coincidence. It's just that then the GDP started growing slower and slower. And then the financial bubbles like the ones put in place by Lehman Brothers just exploded. Okay, just blew up. This could have continued. This financial bubble could have continued if we would have growth. But Ponzi schemes, like basically our entire economy, cannot continue if we don't have growth. By the way, we may see some big problems soon because of coronavirus. Another very important thing to understand is the concept of EROI. EROI is energy return on energy invested. If I want to extract some oil, I will need to first use some oil to extract it. I will need to use some oil to build the infrastructure, the well. I will need some oil to pump the oil out of the ground, and so the minimum EROI that we need for to maintain a rich society, so we don't spend on all our oil to extract oil and refine it, is 8. We need a minimum of 8, a minimum EROI of 8, sorry, if we want to have a rich society, meaning healthcare and family help from the state, or that if you ever want to be an artist, which is something, let's call it unproductive, meaning that it's not about growing potatoes or the survival of the species. I'm not saying that that art is useless. I don't think like this. So if you want to have a society where people can choose freely to do unproductive things, then you need an EROI of minimum 8. What you can see is that the EROI of oil and gas in the 1900 was of 100, meaning if I used 1 barrel of oil to extract some oil, I could extract 100 of those. In the 1970s, when I used 1 barrel, I could extract only 30. In 2005, this was down to 18, and today we're around 12, 14. We're starting to be dangerously close to 8. what you can see is Eroi in real life basically looks like this. Oil whale from the beginning of the centuries would look of like the picture you have on the left. Now we are drilling thousands of meters under the surface of the sea. So you can see that you need more and more metals, more and more energy in order to extract more and more oil, or the same quantity of oil. When people tell me we technology will save us, we will discover more things, I always tell them technology has never been as advanced as it is today. And we have never discovered as few oil, as little oil as we have today. Technology is not the problem. The problem is just that oil is harder and harder to get. So, and you can see that from 2005 we reached the plateau of conventional oil. Don't pay attention to the dark line. Those numbers may not be entirely accurate because it depends on how you count the oil. Sometimes you count some gas as oil, blah blah blah, but they are not untrue. Okay, the general shape of the curve is good. And you can see that the only thing which is right now increasing our oil supply is unconventional oil. We are currently at about 100 million barrel, and so we're gonna talk a bit very quickly about unconventional oil. We mainly have three types of unconventional oil, which is the shale oil in the US, the centaurs in Canada, and biofuel. First problem is that shale oil and centaurs have an EROI of about 4 or 5, meaning you need to invest a lot of energy in order to get some energy out of the ground. And biofuels, even with the 4th generation of biofuel, has an EROI which is less than 3. So all of those are not enough to sustain a rich society. The second problem is the environmental impact of those type of oil. Biofuel, it means you need to put fields everywhere. And when I say everywhere, I literally mean everywhere. Like, for example, if you would transform the entire fields that we have for food into colza fields to to produce some oil, this would amount to about 25% of our current consumption. And personally, I prefer to eat rather than to just prefer to eat than to just have oil. Centaurs are basically open mines, and shale oil, the problem is that you make a hole in the ground and then you reach the peak after 2 months, and then it goes quickly down and you have a long tail of production. So what you do is you make another hole 200 meters further, and then you make another hole, etc., etc. So it's not a problem in the US where first of all, when you own a piece of land, you also own the underground. And it's also not a problem in US because they have a lot of space. And basically the situation is like this. On the right of the vertical purple line, you have the prediction. Mainly, we are at peak oil. This may be in 5 years, but even the International Energy Agency, which is known to be very, very optimistic, said that in order to accompany growth, we would need to triple the US production of shale oil by 2025. The best estimation, the most optimistic, are that it will double. This just doesn't. Peak oil is right now. When you see the curve going down, it's not just oil, it's our entire way of living. It's our economy, it's our comfort of living, it's our standard of living, everything. We are at the top. Congratulations. we're gonna have a quick look at what's happening in Europe. What you can see here is the country which from which Europe is having its oil. In red, you have the countries which already passed their national peak, and in orange, you have Russia, which will, according to the IEA in English, which will have it in 2025, but according to their Ministry of Energy, Alexander Novak, this will happen in 2021. So from 2021, half of our oil supply will be decreasing. Actually, we already are in a decrease of oil, gas, and coal supply. I'm sorry, what we can see on the top left is our oil supply, and you can see that from 2007 we are in it started to decrease. Okay, and this is not because we want it. You will tell me, but we still have growth of oil extraction. Yes, but Chinese people, China took out from poverty 400 million Chinese people, so those people want more oil. And the increase of world production is not enough to give more to Chinese people and to us. So we have less. You can see that our gas supply on the top right has peaked in 2010, and this is the coal production in Poland. Be careful, this is not zero on the bottom of the graph, but basically we lost half of our coal supply in Poland between 1990 and 2015. It's basically the same in all over Europe. It's just that coal is something which is solid, and only 15% of the coal in the world goes through a border. Mostly coal is a domestic energy, and our mines just don't have any coal anymore in Europe, so our production is decreasing. Remember, oil, gas, and coal represents 85% of our energy supply, even in France, where we have a lot of nuclear. In France, it's 80%. 80% of our energy, not electricity, energy comes from oil, gas, and coal. You can see here the energy supply in Europe with all the energy sources, and what you can see is three trends up till the petroleum shocks in the 70s. You have a very big growth. This is the, not sure if you say like this in English, the glorious 30s, golden 30s maybe. From 1980, you have the trend just breaks, and actually if you would have this graph per person, it would be a growth of 0. Here you have the problems with unemployment which start to appear because not so much more energy means not so much more machines, means less people working. You have the problems with debts, etc. This I wouldn't go and analyze it because, as I said, I know next to nothing about economy. And since 2008, energy supply is decreasing in Europe. So the peak has already happened. It's already behind us, and it's gonna get worse and worse and worse. And you can see that this had an effect on our GDP. Average GDP in the 60s was about 5%. Today, if we do plus 1.5% of GDP growth per year, we're happy. So we're going to summarize, because there were a lot of information here. We're going to summarize this first part, which took me not so bad, 1 hour, a bit less. The stream is led by a professional. So we have at the center of our lives the economy, which we will say is our level of life. Okay, in general in the world, if you have a bigger GDP, you have a bigger level of life. We saw that this economy is equivalent to the amount of energy we have. Okay? This energy will have some effect on the climate and on the biodiversity, because most of this energy is fossil fuels. So this releases a lot of CO2, which has an effect on climate. And this energy is used to also do some agriculture with machines and do deep labors, to do some pesticides, so which has an effect on biodiversity. Also, we're cutting down all the forests, so animals don't have places to live. Climate and biodiversity still don't have so much of an impact on each other. We should tell that to the koalas which died in the fire this winter in Australia. But so far, the impact is not so big. We saw, this I didn't have time to explain, but we saw that we need more and more metals in order to extract some energy. Okay, the platforms we need to extract oil are bigger and bigger and requires more and more metals. This we didn't see is the fact that metals are also getting more and more rare, and the concentration in the mines are getting lower and lower. And so we need more and more energy in order to extract metals. Those metals will have some effect, metal extraction will have some effect on the climate or on the biodiversity. Meaning a mine is basically a giant hole where before you had a forest. So, voilà. And in the corner of our mind, we need to keep agriculture. Agriculture needs a stable climate in order to feed everyone. It needs biodiversity with insects, worms, or birds. It needs energy to work the machines, and it needs a stable economy. This is basically the situation we're in. Now we're going to see how the situation we're in is a predicament, why we don't really have a solution. Everyone, I always say, if any solutions which starts with if everyone does that simply doesn't work. Okay, you will never have everyone doing this. If everyone cares about the environment, then we're saved. Yes, of course, but you will never have everyone caring about the environment. First thing to understand the situation, the predicament, is the scale of changes to operate. You have here a graph with on the left vertical axis the temperature increase since 1870, and on the top, on the horizontal top axis, you have the amount of CO2 we've already put into the atmosphere since 1870. This is from the IPCC, and currently we have already put 2.2 gigaton of CO2 into the atmosphere, so we will have plus 1.5 degrees, no matter what we do. If we want to stay under the 2 degrees, like we should, then we cannot emit more than 3,000 gigaton of CO2. This means that you and me can emit during our lifetime about 1/3 of what our parents and grandparents could emit, in a world where there are on average 3 times more people. So our carbon budget is about 9 times smaller than what our parents and grandparents, or mostly grandparents, had. Okay, this will not do with marginal changes. This requires complete societal transformation. But to convince you about it, we're going to see what technology can achieve. Let me present you the Kaya equation. Mr. Kaya, I think he's Japanese, started with a simple truth: CO2 equals CO2. then mathematics allows me to multiply and divide by a same number. So I multiply and I divide by energy. I multiply and I divide by GDP. I multiply and I divide by the population. What did I do here? I made, Mr. Kaya did is that he made 4 terms appear. We're gonna take them from the right to the left. The right in purple is the population, it's the domain of demographs. In blue, you have GDP per person. This is dollar per person. Okay, so this is your purchasing power, how much money you have. In green and red, you have the domain of engineers. Green, you have energy per GDP, so this is the energy intensity of our economy. This is how efficient our machines are. If I need to make a bottle of glass, so I need to melt some sand. If my machines takes 30% less energy to produce the same bottle of glass, then I will produce the same amount of GDP, but I will have used 30% less energy. And finally, in red, you have the CO2 intensity of our energy. This is how much CO2 is emitted when you produce 1 kilowatt hour of energy. Okay, if you do it with coal, it's a lot of CO2. If you do it with nuclear or wind or solar, it's not a lot of CO2. The IPCC tells us that if we want to stay under the 2 degrees by 2100, we need to divide our CO2 emissions by 3 by 2050. So the term on the left side of the equation needs to be 0.33. What you can see is that the CO2 intensity of our energy in the last 50 years has actually only decreased by 5%. Actually, the curve going up is China discovering, oh, we have coal. Hey, let's use this coal, basically. So if I would have taken the last 30 years, I'm sorry, I forgot to say, I made a strong assumption here. I made the assumption that what we did in the past 30 years, we're gonna do in the next 30 years. Okay. So here, if I would have taken the gain we've had in the last 30 years for the CO2 intensity of our energy, it would be more than 1. So I took past 50 years and I said, let's do it in the next 30. Energy intensity of our economy. Here we've been pretty good and we've managed to use 35% less energy to produce the same amount of GDP in the past 30 years. Well, good job, Mr. Engineers. The UN is telling us that the world population should be about 10 billion in 2050, aka LOL. So if we have 0.33 equals 0.95 times 0.65 times x times 1.3, your purchasing power needs to be about 0.4. This means that you and me need to divide our level of living by 2.5 in the next 30 years. Okay? You and me, but also the 2 billion people living with $1 or less per day. Now, since I care about you and I'm very nice, I decide to kill 1 billion people. Let's say that till 2035 the human population goes to 9 billion, and in 2000 then I kill 1 billion over the next 15 years, and it goes back to 8 billion like today in 2050. Okay, so I killed 1 billion people and I prevented 1 billion more from being born. Even with this, we need to divide our purchasing power by 2 till 2030. So technology itself will not save us. And last thing, to understand why technology by itself will not save us, I have nothing against technology. I have something against people who think, okay, I'm gonna continue to live the way I live, and then the engineers and doctors in the white blouses will save me. Um, the thing we need to understand is the Jevons paradox, also called the rebound effect. Jevons paradox is the fact that improved energy efficiency can increase the overall consumption of energy by making an activity cheaper and thus more scalable or accessible. It sounds counterintuitive. Making something more efficient would mean that we use more energy with this thing. For example, internet. Internet, 20 years ago, when we were going on internet, we were watching Wikipedia or text, maybe a few images. Now we're using internet, and data transfer became cheaper and more accessible, so we are watching videos. Car planes have more efficient engine. Planes have reduced their consumption per engine by 30%. Did it make aviation release less CO2? No, it made it cheaper, so more people can afford to take the plane, so increase of CO2. And then you have a few more examples. Housing insulation, when you have better insulation, you may decide to increase the temperature of living. High techs are getting cheaper, so we can afford to change our phones every 18 months. And for example, meat prices are getting lower, so we can have more and more. Okay, when you increase the efficiency of something, you make it cheaper, and then more people can use it. Now we're going to talk about collapsology. So, first of all, we need to define what is collapsology. Collapsology, first of all, it's not a real word. Was coined by French authors Raphael Stevens and Pablo Servigne in their book How Everything Can Collapse, Comment tout peut s'effondrer, in 2015. Collapsology is a transdisciplinary field of study. It's not a science. A science needs to be able to produce to make predictions that we can test. Collapsology cannot make predictions that we can test. And collapsology is the study of the collapse of our thermo-industrial civilization. It uses things like the sciences of climate, the sciences of biology, the sciences of energy, but it's not in itself a science. And one definition which is taken by their author is one which was given by Yves Cochet, who was Minister of Ecology in 2002 in France, is that the collapse of a state, it's a process. So it's not an event, it's a process after which, for a period of over a year, the basic needs of a state's population, meaning water, food, housing, energy security, cannot be provided by governmental services for an affordable price. Can it reach this state? I don't know. What I call collapsology, because of course it's not coined, it's not a real science, so I can give my own definition, is a decrease of energy supply and resources supply, and this decrease will be done when we in a way that we won't be prepared for it. Okay, so this will have societal consequences. I don't know if this will reach the fact that we won't have food in the supermarkets or very expensive food, but I wouldn't bet against it. I wouldn't bet all my money on it either. So we're going to see different type of imaginaries of the future. And to do so, I need to introduce two things, which are the ecological footprint and the biocapacity of the planet. Ecological footprint, we're going to look at the resources that we're using, the waste and pollutions that we are generating, and the deterioration that we are causing. And the biocapacity of the planet is the capacity of the planet to replenish those resources, to absorb those wastes and pollution, or to repair those deterioration. Based on this, Mr. Keller created 4 imaginaries. I just cut the last one into 2. Go and watch his videos. Once again, he talks about it way much better than me. first imaginary would be the imaginary of unlimitist people. Those people think that we are going to be able to push the biocapacity of the Earth. In green, you have the biocapacity, and in red, you have the ecological footprint. So pushing this biocapacity, we've been doing this across the past 2 centuries. So why wouldn't we be able to do it anymore? The problem is that our ecological footprint is having an exponential shape. Okay, and as we could see with coronavirus, exponential means that at some point it's growing very fast. So some people think that Mr. Keller called them sustainabilists. Sustainabilists think that okay, there is a limit, but this limit is still above us, and at some point we're going to stabilize our ecological footprint and we're going to reach a point where we will stop developing and we will just live and stay under the biocapacity of the planet. Sorry for a sec. Thanks. Except that those people are a bit late. The biocapacity is not above us. The biocapacity is below us. And so Mr. Keller thought of another very popular imaginary, which is the imaginary of ecologists. Okay, this is the mainstream ecology imaginary. This is okay. Since the middle of the 70s, we are above the biocapacity of the planet. And okay, our ecological footprint is still increasing, but what we're going to do is that we are going to decouple our standard of living and our ecological footprint. This is sustainable development. Okay, we continue to develop and we decrease our ecological footprint. The problem with this is that this empirical data, okay, the data that we can see from the past years, show that there has never been absolute decoupling between ecological footprint and standard of living. Okay, we have a relative decoupling, meaning that our ecological footprint is increasing less fast than our standard of living, but you never had an absolute decoupling with standard of living increasing and ecological footprint decreasing. Okay, so people who think like this, it's a religion. There are no scientific data, no scientific evidence that we're going in this direction. And it's even worse because in the last few years, with China learning how to play with coal, we have a recoupling. Okay. Then you have a fourth imaginary. Fourth one is collapsologist imaginary. In this imaginary, we don't do the proper things that we should be doing in order to reduce our ecological footprint. The problem is that once the ecological footprint is over the biocapacity of the planet starts to decrease. And here it's gonna start to look like an exponential, but this time not in the good direction. In this universe, we don't do what we need to do. We continue to feel like we're invincible. We continue to say, let's go over the limit, and we collapse. Okay, physics tell us that the ecological footprint needs to be under the biocapacity. It needs to go down. This is not a matter of politicians, not a matter of yes, I want, no, I don't want. Physics tells us that you cannot have sustainably an ecological footprint which is over the biocapacity. Okay. You cannot have sustainably an ecological footprint which is over the biocapacity. And the imaginary for which I fight is, let's be reasonable, let's decrease our standard of living, and let's right now go under, try to go back under the limit. Okay, but like I said, and this would work if everyone would do it. But like I said, any solution starting with if everyone is simply not working. Okay. So this is nice. I made some beautiful graphs on Paint, but what are real scientists saying about it? Welcome to the limits of growth. The limits of growth is a book in which was published a model called the model World Free. This was made by the MIT in the 1972. So the limits to growth was a huge success. It was sold 12 million times, translated into 37 languages, and what they did is that this team led by Dennis Meadows produced 12 models, 2 where we don't care about limits and 10 where we apply solutions. Where we apply solutions from maximum from the 80s. What they found is that unless in only two models, um, we can reach a sustainable development. And in those two models, they made extremely optimistic scenario, like we have access to clean energy, or we have a lot of resources and we take the good political action when it's needed. And those solutions needed to be applied maximum in till 1980. Did I say that before? Not sure. What are those two scenarios where we don't care about the limits? So those two scenarios are the ones that we are following right now. In the first scenario, what you can see is the curve going from the top left, going down very quickly, is the resources. In this scenario, we deplete the resources a lot by big factor, and from 2030 you have a decrease of population. Okay, decrease of population, which follows a decrease of agriculture production and industrial production. Good news is that you can see the pollution on which is the down curve, which goes down. Okay, so this would be a good news for the biosphere and for the climate. In the second scenario, they said, maybe we underestimated our resources, maybe we have more resources, maybe we're gonna do more recycling. In this scenario, they quadruple the resources available on Earth, because it's a computer model. And this time we have a very big decrease of population in black in 2050. Okay, when you can see the curve here is going down, but not so much. Here it's going down hardcore. And what's happening here is that we die because we pollute too much. Okay, because we destroy our environment. So this model has some limits, of course. First, it's not a prediction of the future. It's a computer model. It's a scenario. Okay, same as what the IPCC is saying. The IPCC doesn't make predictions, it makes projections. Second, in this scenario, the resources are considered non-renewable. You have some recycling in order to re-inject the resources into the system, but they are considered as non-renewable. In my opinion, and this is only my opinion, this doesn't matter because the resources we mostly need are gas, coal, and oil. And third, limits, and those resources are non-renewable. Third limit is that this model was made in 1972 when those scientists didn't have access to the work of the IPCC. They didn't know about climate change, and they didn't include climate change effect on the in the model. So when you see here that the pollution goes up and the population dies, this is not the climate change killing everyone. This is plastic pollution, heavy metal pollution, degradation of the biosphere. Okay, but this is not climate change. Climate change goes on top of that. Can we see some signs that we are in a collapsing world? Because as I said, collapse is not an event, it's a process. First is the consequences we can have of a worsening economy. And we saw that less energy growth means less GDP growth. And when we reach the fact that we don't have growth, then problems start to occur. Meaning that if you want to give a bigger share of the cake to someone, if you don't have growth, the size of the cake stays the same, and then you need to give a bit less to someone else. So, according to me, my humble opinion is that a democracy works like this. Rich people can do like this as much as they want, as long as poor people can do like this. This is okay. But in a society without economic growth, when you give more to rich people because they will create job for, of course, right? Then poor people do like this, and then poor people they are not happy. So what do poor people do? They vote. And this is an ongoing trend everywhere in the world. You can see that in Europe we have Brexit, we have Orban in Hungary, the Five-Star Movement in Italy. In France you have the movement of the Yellow Jackets, rise of extreme. Can be left, can be right. Okay, extreme is just a way of the population saying, fuck this shit, I don't want this system anymore. I'm gonna vote for something else. Can be it's because of Arabic and black people, or it can be let's all love each other and redistribute wealth equally. Okay, but in both cases, it's saying fuck the system. And you have a rise of extremes in Spain, Portugal, number of countries in Europe, for example. You have real Nazis now in, well, neo-Nazis in the parliament in Greece. Okay, I didn't include Poland here because even though Poland has an extreme right government, because Poland has had a 23% increase of GDP between 2007 and 2014. So I don't know why Polish people vote for extreme right. Well, I have my idea, but I think it's not related to economy or energy. In America, I think people just turn off their brain 1 year before the election and they successfully elected Trump or Bolsonaro. By the way, I think there is a mistake in his name here. Consequences of worsening economy and inequalities. If you add inequalities, it's even worse. In the last year, and I just took the last year, we've had violent protests a bit everywhere in the world. In Algeria, Egypt, Lebanon, Iraq, Iran. South America is even worse. It's basically the whole continent going on fire. This has been shown in a model called HANDY, a model which was financed by the NASA, that when you add inequalities into society, then it collapses faster and it collapses well more violently and sooner. Let's get to an analysis of our recent history. So this is mainly what Mr. Jancovici says, but not only him. I will get you the sources on the website I'm preparing once it will be online. The Syrian civil war was due to an energetic and climatic stresses. In 2004, Syria reached its national oil peak, and in 10 years they their production of oil decreased by 30%. This meant less money for the state, less money for the people. Between 2006 and 2010, there was an extreme drought, which was very badly handled by the government of Bashar al-Assad. And so this led to the Syrian civil war that we've known in 2010. The Arab Spring was also the consequences, not only but mainly, of energetic and climatic stresses. The economic crisis in 2008 was due to the flattening of production of oil from 2005. So energy crisis leads to economic crisis, leads to less tourism. And then in 2010, you have a big heat wave in Russia, which destroyed half of the crops. And Russia said, this year we won't export our wheat. This led to an increase of the price of wheat. And so people in those countries which were highly dependent on tourism and for which the portion of their revenue, a large portion of their revenue goes towards food, suddenly they had less money and food costed more. And you can see in pictures of demonstration that people were holding some bread in their hand during protests. According to me, we may see a similar CISO effect. Can I say this? Similar effect with energetic and climatic stress in Mexico, Algeria, Egypt, Iran, and India quite soon. This is just my opinion. Collapse. What does it look like? First of all, you need to know that there are only 3 ways to kill a lot of humans. War, but war is not very efficient. Disease and famine. And usually those 3 effects are feeding each other. Okay, if you have war, you will most likely, you may have some famine, which would lead to some disease. Okay. Collapse, it's not an event, it's a process. In my opinion, collapse started already 15 years ago. Collapse has already started, and it's polymorphic. It can take many different shapes. Arab Spring, people voting to go out of European Union, Syrian civil war. But when you go deeper, you look, it's like because we're hitting some planetary limits, okay, in terms of energy, in terms of climate, of biodiversity. And collapse is like plate tectonics. You cannot say, okay, this event will happen at this moment in the future and it will look like this. No, but what you can say is that, like plate tectonics, the more you wait, the more pressure, the more tension you have between the tectonic plates, and the bigger the blow up will be. Okay, so that's a lot of bad news, but can collapse be a good thing? I would like to say that only the way down is hard. Okay, so in my opinion, our generation is fucked, but maybe for our grandchildren it may be good. Once we will be used, but this is just my opinion. Once we will be used to living with less, it's not so hard. Ask a smoker when he's quitting smoking. Okay, it's very hard. Once he hasn't smoked a cigarette in a few years, it's not so hard. Energetic collapse. So collapse because we don't have enough energy, this deregulate our economy, and then you have a domino effect. Could be a good thing, and in my opinion, the only way to save the climate and the remaining biodiversity. Once again, this is only my opinion, but collapse means that we'll have to reconnect with nature. It means that we will appreciate what we have even more. Now we have so much, we have so many gadgets that we can throw away right away because we can buy a new one. when you need to have something, and if you want to have this something, you need to build it, or you need to pay a big price for it, then you value what you have even more. We will socialize with our neighbors. Now, I don't even know the name of my neighbor. I don't even know what he looks like because I don't need him. I don't need him. I have 500 energetic slaves working for me 24/7. Why would I need my neighbor? With the decrease of energy, we will get some link back and link with each other. And finally, we may bring back some sense into our lives. No more bullshit job. In a world with energy, everyone will have to be productive. Okay, no more, I'm gonna do a PowerPoint presentation for a company I don't even believe in. So this was my optimistic thoughts on collapse. Now I have some personal predictions of the future. 15 more minutes and will be good. Um, you will notice it probably won't happen like this, and you will notice that even the first line is already wrong. But it gives a good good way to see the interconnection between energy and um, demographics or things like this. Economic crisis, so 2019-2020, economic crisis due to energy crisis. The world oil production flattens, leading to strong deregulation of the price of the barrel, meaning the price of the barrel will go haywire. 2021-23, in Africa, I see an increase of food prices because one of unstable oil prices, two extreme floods and droughts in major food producing countries. This coupled with water crisis because all of the Mediterranean next to the Mediterranean and next to the Mediterranean Sea, we will be very hardly hit by water crisis because of climate change. So this coupled with a water crisis, a decrease of tourism because of the economic crisis, and the effect of past oil and gas national peak production leads to the collapse of Algeria, Libya, Tunisia, and Egypt. In Europe, Spain, Italy, Portugal, and Greece collapse economically, possible riots in France. I'm half Moroccan, so I had to include this. 2024, I see the US invading Morocco because Morocco has 65% of phosphorus reserves of the world, and the US will want to bring democracy and stability in a region where they see that that it's starting to become unstable. 2023-25, Europe will most likely have spent billions to save its banking system. It progressively sees millions of migrants knocking on its door. As I said, it probably won't happen like this. The first line is already wrong, but that's my small bet on the future. Are there some solutions? We're going to see first national scale solution very quickly because I don't believe that our government will do anything because fighting climate change or resources depletion means using less energy and basically decreasing our GDP. First thing would be to, this is true especially in Poland and in Germany, replace our electricity production from coal by something which is emitting less CO2. In my opinion, nuclear power is better, but if you prefer renewable, go for it. We can talk about it if you have some questions after the presentation. Second of all would be individual and public transport. What I would do if I would be president is that I would give a few billion euros, sorry, to I would give a few billion euros to Renault and Peugeot. I would tell them, you make me a car which consumes 1.5 liter per 100 kilometer, which is about 4 times less than current cars consumption. Uh, because the electrical car can be nice, but in my opinion, it's easier to make a small car because this car needs to be small, light, cannot go very fast, like 110 maximum. Um, and so what I would say is in the next few years, I will triple the price of oil. I pay you. If you give me a car, I give you the new car which consumes 4 times less on average than the average car in the country. Okay, so prices of oil multiplied by 3, but consumption divided by 4. And of course, train instead of European railroad system, instead of the plane, etc. Carpooling, bicycle, blah blah blah. Heating and insulation in European countries, this is a big deal. This is in France about 20% of our CO2 emissions is due to heating. So insulation, um, heating curfew, for example, I could say no, you don't have the right, uh, except if medical assistance for medical reason, to heat your place more than 17 degrees during the night, because you can just sleep with a quilt. And agriculture, we need to completely review the way we do our agriculture. No monoculture, less pesticides use, no deep labor. We need to diversify, to relocalize, and basically help our soils and our biodiversity to regrow and come back. Individual scale solutions. So we saw that the consequences of climate change will be so it depends on the different. What can be done to prevent chaos? I will answer you, Binuts, right after the conference, the lecture. We saw that climate change, biodiversity loss, and depletion of general resources will cause some deaths. Okay, so every resource that you leave for future generation, or just future, every CO2 that you don't emit, it means that you are saving lives. Okay. For example, me, when I go back home, instead of putting the code on my door, I'm using a key each time, and so I'm not using electricity. And each time I feel kind of proud of myself. I'm thinking, oh, I saved someone today. I am a hero. So the first solution would be to lower your impact. We'll go through different ways that you can lower your impact. I will I put some slides at the end of the conference with written all of the things you can do to lower your impact. Please go and make a print screen. I will show them right after. First thing to do is to calculate your ecological footprint. Okay, see where your emissions come from. Average Polish person emits about 8 tons of CO2 per year. French person, I think it's 12 tons. The target we need to reach is 2 tons. Okay, so you see I wasn't joking when I say we really need to divide our CO2 emissions by a lot. First thing you can do is have one kid less. Okay, this is the best thing you can do for the environment. A baby is a human being which will need to be loved, to be heated, to be fed, to have some clothes. So this human being will take a lot of resources. I didn't say don't don't give birth to any kid. I said maybe you could think, okay, I wanted 3 kids. Now, personally, I want just one. become zero waste. Zero waste is not the best thing you can do in terms of CO2. Okay, it doesn't have such a huge impact on CO2 consumption. Zero waste is, to be truly zero waste, you need to produce less than 1 liter of waste per year per person. This is insanely difficult, but according to my experience, it's very easy to get rid of 30% of your waste. It's quite easy average, let's say, to reduce by 50%, and then it becomes more complicated. Okay. In order to be zero waste, you have just one question to ask yourself. Each time you throw something into the bin, you ask yourself, what can I do? How can I change my behavior so I won't produce this waste? Okay. Small example, plastic bottle. No plastic bottle. You can drink the bottle from the tap and have a filter. Okay. Just an example between others. So zero waste is not the best for CO2, but zero waste is insanely good in terms of communication. When people in the shop see me coming and getting my meat or my cheese with reusable container, they see that I'm trying to be eco-friendly, and then maybe they will think, oh, why couldn't I do the same? It's insanely good also in terms of self-esteem. When you cook in a zero waste way, you feel just so good about yourself. This is my personal experience. And last thing is, wait a sec. Yes, zero waste is very nice because you see the effect of the the changes you're making. Okay, you're making some changes and you see that you're producing less waste. When you eat less meat, you don't see that um, that less forests are being cut down or that less CO2 is emitted. Then we need to talk about diet. Diet, this is one of the best things you can do for the environment, is to eat less meat, especially less red meat. I didn't say you have to become vegan tomorrow. Maybe instead of eating beef at every meal, you can do it once every 2 weeks. Personally, I'm flexitarian. I'm eating chicken, small animals. Small animals generally they produce less CO2 and deforestation than bigger ones. So I eat chicken or turkey or even pork, which is not so bad in terms of CO2, but worse for some other things, twice a week, and I eat some beef once a month. And when I eat some beef, I take the good pieces of beef. um, Also, try to eat more local. Try to eat more seasonal. Right? Big thing you can do also is re-evaluate your need, reassess your needs. Do you really need this new thing? Uh, if you need it, I don't remember the sentence. Something, then it's a need. Never mind. Um, Sorry, I'm tired because of talking too much. Reassess your needs. Can you avoid buying new stuff? Can you repair your old one? Can you borrow it? Can you rent it? There are 1 million things. You can also boycott and boycott. Boycott, it means don't buy things in places which are destroying the environment. Boycott is buy things in places which are good for the environment, or at least better. Transport, here also you don't need to say, okay, I'm never going to take the plane ever again. I'm never going to take my car ever again. Personally, I live in Poland. My family is in France. What I do is I limit myself to 3 plane ways per year instead of 12 like I was doing before. Okay, I divided it by 4. because the train is very expensive and the bus takes 24 hours, and I live in the eastern part of France. So yeah, I do what I can. Same thing, you can tell yourself, okay, I'm going to carpool. I'm going to take my bicycle twice a week to go to work. Housing would be more about trying to have a more efficient house. Can redo the insulation, but this is very expensive. Very good way would be to install um, tap water pressurizers on the tap. Or on your shower panel. This reduces your water consumption by up to 70%, and it costs €5. Other thing that you can do is, for example, I'm getting the water from my bath, or my shower. I'm putting the plug in the bathtub. I'm getting the water from my shower, and I'm using it to flush. I mean, we're gonna have severe water crisis in the next 10, 20 years maximum, and we're literally pooing and peeing in drinkable water. Yeah. Online, you also can be more sober. This goes through store less things online, delete your emails, don't store the video online, your pictures. A hard drive is just enough. Maybe you don't need to share 20 pictures of your kid to all your Facebook friends per day. Okay. Also, when you watch a video, you can watch it in lower quality. And finally, you can change your bank. Change your bank the bank is using your money to invest in some things, and you don't know in what they are investing. If you go to an ethic bank, then they assure you that they will, sometimes you can even choose, they will invest in such type of projects. So this was reducing our impact, but this won't save you from collapse. Then you need to become more resilient. More resilient means that if there are some shocks, you can absorb them. How do you do to produce your electricity? Solar panel, you can do some small wind turbine. How do you do to heat your house? You can do yourself some thermal solar panel. How do you do to heat your water? How do you do to cook? Maybe with a solar cooker, or you can produce your own biogas. Okay, you need to be able to grow your food. You need to also be able to be, I forgot to put it, be sufficient with water. It's not about being 100% autonomous, it's about being as much as possible. And you need to think also about how to handle your waste. Okay, what do you do with your poop and your pee? What do you do with the things that you may still buy in supermarket? What do you do if tomorrow there is no one to get your waste? And finally, almost finally, is networking. The first thing you need to do is to get informed. Watch for the signs of the collapsing world. You need to be aware. You cannot prepare for something you don't understand. A very good French group is on Facebook is Transition 2030. I love this one. In English, I don't know. I'm sorry. And a lot of the informations I got for this conference, I got them from studies which were published on this Facebook group. Inform others. The more people will be eco-friendly, the less we will go down. And finally, build a network. You cannot be autosufficient by yourself. What if your solar panel breaks? Can you repair it? What if you don't have enough food? What will you do? You need to build a network to be in relationship with others. And finally, and this will be my last advice, you need to enjoy life. Okay? Enjoy life as much as you can. Right now, we are in a world where we have energy. where we can allow ourselves to go on holidays on the other side of the world. I'm not saying you should or shouldn't do it. I'm saying try to enjoy life as much as possible without destroying, without overreaching our limits too much. Okay? If you're under 2 tons of CO2, then you got it. In my opinion, we have anything between 2 and 5 years before we seriously need to prepare for collapse. I'm not saying collapse is in 5 years. I'm saying that you need time to learn how to grow food, to establish a farm, to make the biodiversity comes back, to build a network, to prepare and create a community. Okay, so this time we have right now, it's an amazing time. You need to enjoy it. Thank you very much. Was good? Was good. This was good. And for those of you who want, I invite you to make a print screen of this, 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 and this. Yes. Thank you.